Yeah, hello everybody. So today we'll discuss about some of the questions that were asked in your weekly quiz, daily quiz for second week of May month. Okay. Mostly it is focused on calculus topics, and some questions from probability are also there. Okay, so we'll see those, and okay, let's do that. So the first question is, the minimum and maximum of this function f of x is a cubic function or cubic polynomial, but they have mentioned some range for x as well. Okay, and you are supposed to find minima and maxima. So 4 options are there. Just by looking at the options, you can tell 1 and 3 are involved. Okay, so now the question is about the sign of them. No issues. Let's see. Okay, so this is the case of function of single independent variable maxima minima. So it's a standard problem, and the standard solution methodology is first you need to get the critical points for this f of x. Okay, and that you do by differentiating once with respect to x and equating it to the 0. Then you get the roots for that f dash of x equal to 0 equation, and then we call those roots as critical points, and at each critical point you verify whether it's local maximum or local minimum. Okay, and for that you use the second derivative test. So you calculate f double dash at every critical point. If it is negative, then we call it as maxima. If it is positive, it's minima, usually local minima, local maxima. If it is 0 and the next derivative is non-zero, then that's the inflection point. But if the next derivative, the third derivative is also 0, then you can't say for sure. So you need to verify till the nth derivative is 0 or not. 0 or not. Okay, non-zero. Okay, so let's solve this one. So you have f of x equal to x cube minus 6x square plus 9x plus 1. Okay, yeah, and also x is belonging between range 0 to 5 excluding 0 and 5. Okay, open brackets. So let's first find critical points. So for that you need to find f dash of x first. Will be 3x square minus 6 into 2, 12 plus 9. Equate it to 0 and solve for this. So from here you can take 3 common on the LHS, and you will have just x square minus 4x plus 3 equal to 0. So that is nothing but x minus 3, x minus 1 equal to 0. Okay, and therefore the critical points for this f of x come out to be x equal to 3 and x equal to 1. Now before using the second derivative test, you should always keep in mind they are talking about a particular range. So both of these critical points fall within the range. Okay, so if you look at the options, just by looking at the options and this piece of information, you could have just told option B should be the right answer, because in option A there is -1 which lies outside 0 to 5. Same goes for option C and D. Okay, so option B should be the correct answer. So without doing anything, if you are confident enough, you should just tick that. Or if you don't have time towards the end of your exam, you can just tick option B, and that is the correct answer also. But anyway, let's do it conventionally. Now you have to check at x equal to 3 and x equal to 1 what is happening to the second derivative. Okay, so what is second derivative? From here only you can calculate. That will be 6x minus 12. Okay, so you need to check this value at each and every critical point. So let's do that. So at x equal to 3, yeah, so at x equal to 3, the second derivative value is nothing but 6 into 3 minus 12. So that is 18 minus 12, 6. That is greater than 0. So this is a local minimum. Okay, so at x equal to 3 you have local minimum. Similarly at x equal to 1, if you take the value of the second derivative x equal to 1, it turns out to be 6 minus 12, that is minus 6. It's negative. So that's a local maximum. Okay. But yeah, before concluding this thing, you should always check the values of function at the endpoints of the range. So since 0 and 5 are not included, what you can do is you can calculate the value at, let's say, just close to 0 but slightly inside. Okay, and that will be basically you have to put you know, in the f of x equal to 0. If you put, you'll get 1 because all the x terms goes away. Similarly, you can evaluate 5 minus. That means we are not exactly at 5 but just below the 5. Okay, so that will be nothing but 5 cube minus 6, 5 square plus 9 into 5 plus 1. Okay, so that is 125 minus 50, minus 150 plus 45 plus 1, that is 46. If you do this, you should get 21. Okay, 25, not 21. Or 1 second, minus 25, yeah, 21, because minus 25 plus 46 should be 21. Okay, and just for the sake of this thing, what is the value at f of 1, because that's one of your critical point. It is 1 minus 6 plus 9 plus 1, so that is 11 minus 6, so that is 5. Okay, and f of 3, because that is the second critical point. F of 3 turns out to be 3 cube minus okay, I'll write it, 3 cube minus 6 into 3 square plus 9 into 3 plus 1. Okay, so that is 55 minus 54, that is 1. Okay, so now you see one critical insight that you can get is at f of 1 the value is 5, but at the end of your range near to the plus 5, x equal to plus 5, the value of the function is even higher. So this is the global maximum, you can say. But in this question, actually, it is not clear what they're asking. They're asking about local or minimum. So that's why I was going by options. Okay, so what do we have? The answer is 1 as local maximum and 3 as minimum. Okay, so 1 as maximum and 3 as minimum. Oh, there is a typo here. See, this should be first because 1 has maximum, 3 has minimum. Okay, so there is a typo in this question. Also, it's not clear whether it's local or global. So since we have to choose one option, we should choose option B. But this question is not entirely correct. Okay, there are some incompleteness in this question. Okay. Anyway, I hope you get that. So let's move on. This is about the maximum minimum of a function with single independent variable. This is second question, which is talking about probability of events. Okay, so there are two events A and B, and they are independent if and only if. Okay, and there are 4 options, but these 4 options are not the definition of independence. Okay, so we call these events A and B are independent if probability of A intersection B is equal to probability of A multiplied by probability of event B. So this is the classic definition of independence of 2 events. Basically, you have to use this definition in these options. Okay, so the first option is nothing but your inclusion-exclusion theorem or addition theorem of 2 events. It is nothing but, the standard theorem is A union B is given as, and I think most of you will know this because this is taught in previously also, not in your graduation also, it is taught previously also. This is the real thing, and since if the events are independent, you can write this as minus PA PB, okay, which is your option A. So that means it is a correct option. Okay, let's verify other 2 options because that also we should check before moving on. But it's clear that the option A is correct answer. PA given B is equal to PB. That's your second option. See, this is called as probability of, this is conditional probability of A given B. Okay, that means event B has to happen first. So probability of event A happening after the happening of or occurrence of event B. That is what conditional probability means. And the standard formula is nothing but, it is P by probability of A intersection B divided by probability of B. So this is the standard formula for conditional probability. Okay. And now let's say if the events are independent. Okay. So in that case, this intersection will be just product of individual probabilities, event probabilities, and then it should be equal to PA. But here RHS is given as PB, so therefore it is not correct. Okay, if it is equal to PA, probability of event A, then it should be correct option. And similarly here also, see, this option itself is wrong because this is incorrect statement. Okay, this is leave the independence or dependence. The statement itself is incorrect for any events A and B because this term is wrong. As I shown here, probability of A condition B should be probability of A intersection B divided by probability of B, not A. Okay, because of this, the statement C itself is a wrong statement. You can't say anything. And since B and C are wrong, the D option is also not. So option A should be the correct answer. And if you look at the key also, it is option A. Okay. So interesting question, but the only thing that you are supposed to remember for solving this question was this classic definition of independence of two events, and the definition of conditional probability. This is also called as conditional probability. We have discussed this term and definitions quite extensively in our regular classes. So I hope you guys, those who have attended those classes, would be able to solve this in a very short amount of time. Okay, there was nothing much here. Okay, so let's go to the next question. Now this is a maxima minima, but the function is having two independent variables x, y. Okay, so this is a different case than the first problem. So it's again a cubic function in x and y. So they are asking us to find maxima and minima. Okay. So here also it's a standard problem and there is a standard methodology to find the solution. The first you find the gradient of this function f. So grad f equal to 0. So that means del f by del x equal to 0 and del f by del y equal to 0. So these two equations will give you critical points. And then at each and every critical point, you are supposed to check the determinant of Hessian matrix. Okay, there is something called as Hessian matrix in this kind of functions. So that is f of xy, yx, and f of yy. Okay, so f of xy means second derivative with respect to x. Okay, partial derivatives we are talking here. Okay, so basically you define something called as Hessian matrix. So in the previous case there was first derivative test to get the critical points, then the second derivative test to get the maxima or minima. So here also you take the first derivative, that is gradient, because it's a function of two variables, equate it to 0, get critical points, and then second derivative test is basically talked in terms of Hessian, determinant of Hessian matrix, and depending on the nature of the determinant as well as f of x term. Okay, so we'll see those things, but that is a standard process. So let's go and solve this. So you have f of xy, I'll just call it as f. Okay, x cube plus y cube minus 3x minus 12y plus 20 minus 3x minus 12y plus 20. This is your f of xy. So to get the critical points, you are supposed to equate the gradient of f to 0. That also means del f by del x. Okay, so that is nothing but fx. F subscript x has to be 0. So that will be 3x square minus 3 equal to 0. Because y we consider as constant when you do the partial differentiation. And second is del f by del y. I'll call it as fy. Also has to be 0. That is 3y square minus 12 equal to 0. Okay. So from first equation, you can write x square equal to 1. Right? Because x square minus 1 is equal to 0. So x can take values of plus minus 1. From here you can write y square equal to 4. That means y can take values of plus minus 2. Okay. So therefore you have 4 critical points here. Okay. Critical points are 1, 2 and 1, minus 2. And similarly you will have minus 1, 2 and minus 1, minus 2. So there are 4 critical points here. Okay. And now you have to check the Hessian matrix determinant and f of xx second derivative sign for each and every critical point. Okay. So let's evaluate this f of xx, that is second derivative with respect to x, partial derivative obviously. That turns out to be 6x. Similarly, f of yy also turns out to be 6y. And f of xy, which is also equal to f of yx, turns out to be 0, right? Because fx and fy are functions of x and y only. Okay, so if you differentiate y, it will be 0. Okay, so your Hessian matrix is nothing but 6x 0 0 6y. So determinant of this Hessian matrix is nothing but 36xy. Okay, and then what you are supposed to do here is basically at each and every point, critical point, you are supposed to check. Okay, and the conditions are, I'll just give you the standard thing. If determinant of h is greater than 0 and f of xxy is greater than 0, then that critical point is local minimum. Okay. Similarly, this is first case. Second case is if the determinant of Hessian matrix is greater than 0 and this is negative at that critical point, it is local maximum. Okay. And third is if this gradient of determinant of Hessian matrix is negative, then it's a saddle point. Okay, so now we have to check this for all the points. Okay, so let's go one by one. So let's take first critical point, which is 1, 2. Okay, so at 1, 2, what is determinant of Hessian matrix? 36 into 1 into 2. So that is 72. It is greater than 0. fxx is 6x. That is also just 6 here. So it is greater than 0. So this is, this is a local minimum. Okay. And at 1, minus 2, Hessian will be negative because 1 is negative. And fxx, see, if Hessian is negative, no need to check fxx. That should tell you it's a saddle point. Okay, no need to further calculate anything. Let's check at minus 1, 2. Here also Hessian will be negative because one of the coordinate is negative. So that is also saddle point. And at the last point, which is minus 1, minus 2, determinant of Hessian matrix is positive, 36 into 2. And fxx is minus 6, that is negative. So therefore, this point is your local maximum. And that is the solution. So what they are asking in the question is maximum and minimum, right? So yeah, maximum and minimum. So maximum is minus 1, minus 2 and minimum is 1, 2. So option D should be the correct answer. Yes. Okay. And that is also true as per your answer key. Okay. So very good question. It checks every knowledge of your concept about maximum minimum of f of xy. Okay. One more additional difficulty that they can give you is, instead of giving xy as infinite number range, if they can give you xy bounded region also. So in that case, you have to check the function value at all boundaries also. So that becomes very tough. Okay, so that is also possible. So please expect such things. Now they have given the fourth question, which is on random variable. Okay, so x is a random variable with density, two-part function definition, and we are supposed to find the value of this c, which appears here. Okay, it's a very standard question, and since it's a density, that means it's a continuous random variable. This PDF or PMF, they all have the property that if you integrate, since like we are talking about PDF here, but in case of PMF, it will be summation. So if you integrate this density over the full support minus infinity to infinity, it should be equal to 1, because that is nothing but summation of all the probabilities, basically. That's why it has to be equal to 1. So here, the function is non-zero only between 0 and 1. So the integration limits change to 0 to 1. And you are basically supposed to evaluate this integral, and it has to be equal to 1. Okay. So let's do that. So now C is the constant of, it's a constant, so it comes out of the bracket. And, the integrand becomes x square minus x cube dx equal to 1. So therefore you have x cube by 3 minus x power 4 by 4, limits 0 to 1. Okay. So therefore C into this becomes 1 by 3 minus 1 by 4, and lower limits are 0, so that doesn't come into the picture. So this is nothing but C into 4 minus 3, 1 divided by 12 equal to 1. So therefore C has to be 12. This is the answer. So it's a very standard question asked many times in your previous GATE exam. The nature of this f of x will change, but the key idea is the integration from minus infinity to infinity with respect to x has to be equal to 1. And in PMF, the summation from values going from minus infinity, because those will be distinct values. So wherever it starts till whatever maximum you can have, that summation has to be 1. Okay. So this is a very standard question. You should be able to do this. We have done many problems like this in our classes. So again, same. This question is same as the third question. So I'll just solve it because the theory I have already told. So here they are asking you to find saddle points now. So first thing is to make the gradients 0. That means to get the critical points, that means first derivative has to be 0. And what is first derivative with respect to x? That is 3x square minus 3. It has to be equal to 0. So this will give you x square equal to 1. So that means x is plus minus 1. I think the same conditions will come. Okay. So here also fy has to be 0. That is nothing but 3y square minus minus 3y square plus 12. That will be minus 3y square plus 12 equal to 0. This will also give you y square equal to 4. That is nothing but y of plus minus 2. Okay, so again, same set of critical points also here you get. Okay. Okay, so 4 choices. 1, 2, 1, minus 2, minus 1, 2, and minus 1, minus 2. Okay, and same. Then you have to do the Hessian test. So for that, you are supposed to check the fxx. So that will be nothing but 6x. Fyy comes out to be minus 6y here. Okay, and this fxy or fyx comes out to be 0, because fx is only function of x. So it will be 0. Therefore, your Hessian matrix in this case is nothing but 6x0 minus 6y. Okay, so determinant is nothing but minus 36xy. So this is the only difference as compared to the third problem. So now let's check at each and every point. Okay, so at 1, 2, the determinant of Hessian matrix turns out to be negative. Okay, because that's a minus sign is there now. So therefore it's a saddle point. No need to evaluate fxx. Okay, so first option we got. So 1, 2 is saddle point. Okay, so in these options, eliminate these two directly because only A and C has 1, 2. So let's check at 1, minus 2. What happens at 1, minus 2 point? Because then option A is correct answer or not will become clear. So determinant will be positive in this case because of -2, and fxx is also negative. Okay, so this means it's a local maximum. Okay, so that's why option A is also not correct. And by elimination, C has to be correct, but we can just check -1, -2. Okay. Asian turns out to be negative. Yeah, so that's the saddle point. So no need to check the fourth case because that's not what is asked. Okay, so correct answer is option C, and that is also given in your answer key. Okay. So this is more or less, the different version of third problem, but the process remains same. Okay. So I hope you guys are understanding the importance of that maximum minimum of f of x y topic. Okay, so this is your last question in this quiz. This is a probability question again. So basically, they are trying to frame this question in terms of cricket because it's India. So anyway, so what is happening is India is playing 2 matches each with West Indies and Australia. Okay, so we'll use W and A and I for noting these three teams. Okay, and India can get 0, 1, or 2 points depending on the result. Usually, if you lose, you don't get any point. If it is a draw, 1, and if it is a win, 2. And the probability of India getting those points is 0.45, 0.5, and 0.5. Okay. So another information is outcomes are independent. That is usually the case because otherwise it becomes conditional probability questions. Okay. So now in this question, what they're asking is probability of India getting at least 7 points. Okay. So at least 7 means, at least 7. So 7 and 8 are allowed. Because see, India is playing maximum 4 matches, 2 with West Indies, 2 with Australia. So assuming India wins all of the 4 matches, it will get 4, 2, 2, 2, 2. So 2 plus 2 plus 2 plus 2 plus 2. So 4 plus 4, 8. Okay. So maximum is 8. And 7 is also included because at least 7 is the condition they're asking. And 7, see, total points equal to 8. This happens when India wins all 4 matches, right? So it beats Australia and West Indies in all 2 matches. That is one case. But if you want the total points to be equal to 7, when is it possible? It is possible with 3 wins plus 1 draw, right? Because if you have 3 wins and 1 loss, that is 6. That cannot be 7. So 1 draw is required because then only the sum will be odd number. Okay, so 3 wins and 1 draw. Okay, so India needs to win 3 matches and 1 draw. Then only you'll get total points of 7. So basically, you are supposed to find the probabilities of these 2 events. Let's call this as event 1 and event 2. And the total probability will be probability of event 1 and probability of 2. Okay, so your final answer that you are supposed to get is probability of event 1 plus probability of event 2. Okay. So let's calculate probability of event 1 because India winning all matches. What is the probability? Because India winning a match is 0.5. So all the matches winning is nothing but India wins first match also, and second match, and third match, and fourth match. Okay, this is nothing but this principle of counting basically. If you can do one task in m ways, other task in n ways, how can you do these 2 tasks combined? That will be m into n. So basically, the same thing we are using. So 0.5 square. So that is 0.25 into 0.25. So that will be 0.0625. Okay. So the first half of the question is done. Now let's talk about this. You want 3 wins and 1 draw. Okay. So you have total 4 matches. Okay. And you need 3 wins. Okay. So let's
You are currently the only person in this conference.
Okay, so India, let's say, wins 3 matches initially, and there is a draw. Fourth match is a draw. So what is the probability in this case? Winning is 0.5, 0.5, 0.5. And draw is, I think, 0.05. Okay. But see, it is not necessary that India will draw its last match. This draw can happen here also, or here also, or here also. So therefore, the total probability of this third event, event number 2, is 4 times of this 0.5 into 0.5 into 0.5, okay, into 0.05. Why? Because I hope you guys understand. See, the same question was asked in the last year's GATE also XE paper. Okay, it was in the context of cards, but the same idea that this draw does not have to be happen in the last case. Okay, so there are 4 possibilities where draw can happen, either first or second or third or fourth. Okay, so that's why this 4 comes into the multiplication, and then the rest is calculation. So 0.25 into 5 is 0.125, into 4 is 0.5, into 0.05 is 0.025. Okay, and therefore your total probability of India getting at least 7 points is nothing but sum of these two. So 0.025 plus the previous one, which was 0.0625. 0.0625. So that turns out to be 57802. So 0.0875. And that is your option number B. Okay, same as the key. Okay, so this is how you are supposed to solve these type of questions. And I think this is the last. Okay, so we'll stop here and we'll meet in the some other video next time. Okay, bye.